8 reminders. I should be able to remember. All right. So, sir, I like to split up like this. I like to say the acceleration. So, what are the two accelerations involved?
-9.
-9. And? No, right. The acceleration, I don't know. All right, moving forward. I'm going to go ahead and start. Where do you want to start?
Start with the velocity equation, I guess.
On the left side, on the early, when it's hitting the brakes? Okay, so V equals V naught plus AT. 45. Oh, that's not right. Oh, totally wrong. Totally wrong. V equals 45 plus -9 times how much time it takes before it hits the barrier, correct? I don't know that time, so that's two unknowns. I cannot solve that problem.
Yeah.
Next.
So here's the distance.
Distance equation. So I'm going to go D equals 1/2 AT squared plus V naught T. I know I'm going to go 60 meters. And that's equal to 1/2. What's my acceleration?
-9.
How much time? Initial velocity. 45 times T. By the way, if you ever get a chance to talk to Mr. Bellotti, he has a calculator with the quadratic equation on it for TIs, and he has the cable to give it to you in like an instant. So you have to go find him. I know you're not allowed to find him, but what I don't know doesn't hurt you. I understand he wants a cookie though. Just saying. I made that up. He didn't look like his side. I said, give him a cookie. And look at his face was, what? Mr. Bellotti, you don't like cookies?
No, I like cookies.
All right, good. Get him a cookie then. All right. For a second there, I forgot he's even listening. Okay, let's get a time here. I'm going to get on my Casio because I'm too lazy to do it the hard way. And menu, equation, polynomial. I used to pretend I'd do the quadratic, like negative b plus or minus. Like look, I do it really fast. Things I do to amuse myself. Here we go. I got 1.58 seconds, and I got 8.42 seconds. We got a problem, though. How can I have two positive answers? Mr. Kerrigan.
In this case, I'm not sure.
Fair enough. So the equation says as long as this is true, as long as you have v equals v naught, as long as your acceleration is 9, -9,
Yeah.
this equation is going to work. Which means you would hit the barrier twice if your acceleration stays at -9. Now, why is that unreasonable for the constraints of this problem? As long as your acceleration is -9, you're going to hit that barrier twice. Once at 1.58 seconds, one at 8.42 seconds. Why is that unreasonable given what we know about this problem?
Is it because we have the initial velocity?
No. It boils down to this. What the equation is saying is that if the barrier is in front of me and I start walking towards the barrier, when I hit the barrier, if my acceleration doesn't change, I'm going to keep going, and then I'm going to roll to a stop. And then I'm going to start backing up and hit the barrier again on the way back. Now, we know that's ridiculous because the moment you hit the barrier, what's going to happen to my acceleration? So my equation stops working. So 1.58 is when my equation stops working. I don't need to worry about that second one. It can't be reasonable. Right? Boop. Now I got 1.58 seconds. I'm not sure why I want that. What do I want that?
So you can plug it in.
Plug it in here for the final velocity here. I can do that. So 45 minus 9 times 1.58. I get that the car is now going 30.8 meters per second at the end when it strikes the barrier.
Rosny,
Yes, sir.
I can't see the screen.
Screen? Oh, that's right. You're late adder. We got to unadd everybody else and add you back in. Here, hold on. Got this? Your device. Oh, God, I hate this screen. I don't want this screen. Go away. Go away. All right, I'm going to try it anyways. It never works out great for me, but whatever. Okay, I'm going to do this, and then I'm going to do this. And I'm hoping I just didn't destroy it forever. How you guys looking? You guys can see it now? Now I can't even hear them.
Yeah.
Oh,
Yeah, I can see it.
All right, here we go. Move forward. Okay, so now I got the acceleration of the barrier. I'm going to do this side of the problem, right? What do you suggest, sir?
I suggest the velocity.
Let's do velocity. V equals v naught plus at. When I hit the concrete barrier, what's my final velocity?
It would be 30.7.
No, not my final velocity.
Wait, isn't that what we just calculated?
That would be the speed I hit the barrier with, which would be my initial velocity.
Oh yeah, that's initial velocity. So we don't know final velocity.
Oh, yes, we do. You hit a concrete barrier, you know your final velocity. Zero, yeah. We forget oftentimes this is not a math class. This is a science class, right? You're running into a barrier. You're not going anywhere at the end of that day, right? We don't do enough labs in here, but we will, once they take away our mass, or get my act together and do the mini labs better. Okay, so what's acceleration while in contact with the barrier?
That's what we're trying to find out.
All right, that's good news. What's the time we hit the barrier? How much time are we in contact with the barrier?
We hit it at 1.58.
Yeah, but how much time are we in contact with the barrier?
Oh yeah, right. It's oh wait, not sure.
Not sure. That's a big bummer because that means we can't solve that problem, right?
Yeah.
All right, I'm down to one last idea. What is it?
Use the
Distance equation. D equals 1/2 at squared plus v naught t. How much am I displaced?
0.45.
How did you get that?
It said I went 4.45 meters deep in the concrete barrier.
All right, it says a dent's 0.45. You assume that your car went that, made the dent, right? So that's fair.
Yeah.
That's exactly right. Okay, what's my acceleration?
Acceleration is
Time. Oh, terrible. Initial velocity. At least got that. 30.8 times t. Can't solve that one either. But now I have two equations, two unknowns, which means now I do what?
you get like 7 equal somehow.
Isolate a variable and plug into the other one. Which area are you going to isolate? And then which equation?
You would isolate.
All right, I'm going to take this from you. I'm not going to monkey with this formula. It's icky.
Yeah.
So I'm going to isolate in this one. And I told you never, ever, ever isolate for t, unless you like pain and suffering. It's not illegal. It's just pain and suffering, and why would you do that? So I'm going to say go 30.8 equals at, and I get a equals negative 30.8 over t. Agreed?
Okay, so that was. So I can't really do that.
Uh-oh.
What is that equation that you circled that?
They have 30.8 over t equals a, right? Just move anything around. So I'm going to write bigger for you? Or I'm going to move you forward, huh?
No, that's fine. I mean,
I went through high school with it. That's fine. It's not a good way to go. Trust me. All right. With that in mind, I replace my a with that equation, which is negative 30.8 over t times t squared plus 30.8 t. I get 0.45 equals negative 15.4 t, because one of the t's cancels out, plus 30.8 t's. And 0.45. Ms. Valisic, you ask your question, you're good. Look like you popped up.
I'm good right now.
Okay, look like you popped up for a second. I want to make sure I was hearing you. And so the time it takes to stop is 0.0288 seconds. Now, fun fact of the day, because you need fun facts to keep your brain working on something like this. How does this proceed, this time frame proceed by a human being? is really, really short. In fact, this is faster than the frames in a motion picture. Why is that important? Because in a frame in a motion picture, what they're doing is taking a picture. That's how you see things moving, right? Your brain is tripped because it's moving so fast you can't see the stuff in between the frames. Your brain cannot detect that time frame. So when somebody tells you about a car accident with like a concrete barrier and how it felt, how things were flipping around and stuff, the brain can't actually record it. You'd be lucky to get one snapshot of the whole entire thing. Your brain then figures out the rest. It makes up all the rest of it. Like, oh, that must have gotten there because it came out of my pocket, and that must have, everything else is equally. And that's why police officers, when they talk to you after a car accident, they pretty much are ignoring you. I mean, they take your statement, but they know you're making stuff up because you have to. Your brain just says, well, I must have flipped over 4 times. Yeah, I don't think so, but whatever. You think you did, right? You can actually put it in the little pictures. It's a fascinating little thing in humanity, but that's not physics. That's hopefully psychology. Hopefully they tell you fun stuff like that. Psychology, throw it in there. 0.8 divided by shift answer, and I get, oops, except I didn't do that right, 30.8 divided by 0.0288, and I get 1,070 meters per second squared. Another fun fact of the day. According to the Department of Transportation, 30 G's, or 3 times the acceleration of gravity, which is roughly 10, right? 9.8, is a maximum your body can take without potentially dying. So in this car accident, how are people doing? They're not doing great. 30 times 10 is 300. That's 1,000. At that point, your seatbelt will kill you. If you're not wearing a seatbelt, the glass will definitely kill you. Okay? Car accidents are dangerous because you slow down too fast. Your acceleration is too large. Most of what we try to do when we're trying to make you safe in a car accident is slow down the acceleration. You decrease the amount of acceleration your body feels for a shock. Again, 300 meters per second squared. That's lethal. Now, why tell you these arcane, stupid things? Because of this. When you're checking your answers on a test, please make sure the bicycle stops itself at negative 5,000 meters per second. I'm going to take away a lot more points for that answer. Why? Because you should know better. Bicycles can't stop like that. They don't cause people to die because they hit the brakes. Right? That can't happen. I guess if you hit a tree or something, or concrete barrier, but even then, no. Good? All right. Look forward. Do number 2. You should go do number 2 now.